Hello everyone, this is Casey from 8 Crazy Hearts, and this is Makutu, a generative sequencer, a quantizer, or a quantized generative sequencer. Now, especially with this being a sequencer, it is smaller, but there are a lot of features to it to explore, so I think the best way to go about this is to just start patching and then go from there. So we just patched the clock out of Makutu into a buffered mult that's sending out signals to trigger and sync with a variety of other modules. The knob at the top controls the internal clock rate. The jack on the left side is for syncing with an external clock source. The clock rate knob at that point becomes useless, but if you want to use Makutu as a clock through, you can do that, and then the cable that we have patched currently is where that clock comes through. Much like Music Thing Modular's Turing machine, the big knob in the middle is what controls how random the sequencer is. The LEDs on either side of the knob denote how high the voltage is at that particular moment in the shift register. When the knob is at 12 o'clock, all outputted voltages are completely random. When the knob is turned completely counterclockwise or clockwise, the sequence is locked and will just repeat from there. All the spaces in between bring about either less or more randomness to the sequence. Let's patch the unquantized sequence output to the volt per octave input of our oscillator. So at this point, the sequence is completely random. The knob is at 12 o'clock, and so the pitch values are completely random. But as we turn it all the way to the left, we lock a sequence. As we turn that knob from fully counterclockwise, we introduce more and more randomness to the lock sequence. And then back to 12 o'clock for fully random. The three-way switch on the right-hand side of the module adds 3 ways that you can further influence the randomness of the sequencer. The range knob on the left-hand side of the module controls all 3 parameters depending on which way the switch is flipped. When the switch is flipped in the top position, the range knob controls the length of the sequence. From 4 steps when fully counterclockwise to 16 steps when fully clockwise. Flipping the switch to the middle position allows the range knob to control the width of the sequence. The width is the difference between lower voltages and higher voltages. When counterclockwise, the difference between the higher and lower voltages is small. When turned up, the range and difference between those voltages increase, jumping octaves. Controlling the width parameter in real time can add little variations to an already locked sequence. Flipping the switch to the bottom position controls the number of refrains in the sequence. As locked sequences already repeat on their own, refrain is best to use when the sequence is completely random. Let's turn the step count down to 4. And up the refrain amount. Now that randomly generated sequence will repeat for a number of bars set by the refrain amount, and then generate a new sequence and repeat that, and so on. And that is the sequencer section of this module. The gate output directly next to the regular output is just an output that generates gates based off of where the shift register is. This can be used for fun, drum gates, or things like that. The lower section of the module is devoted to the quantizer. Now, the output of the sequencer can be patched independently, but it's also normaled to the input of the quantizer. This means that the quantizer could be used by itself, but it also means that you only need to patch from the quantizer's output to send out a quantized sequence. The big knob in the bottom left changes quite a few things about the sequencer, but at its basic level, it changes what scale we're in. The red LED denotes that we are in the chromatic scale. If we turn the knob to where it now shows a white LED, we switch to octaves. And if we turn it again, pink mode is minor pentatonic. Let's change a few settings to make this even more musical. The blue LED is natural minor. The cyan LED is major pentatonic +7. The green LED is regular major pentatonic. And orange is regular major scale. The white knob in the bottom middle controls the slew, or portamento, between the notes. The encoder's secondary function is to change the root note of the quantized scale. To access that, press and hold the encoder knob in, and then turn it. The trigger output sends a trigger signal out every time a new voltage, or in this case, note, is sent out. That means if the same note is played twice, only the first note will send out a trigger. The CV input of the module can control a variety of things, and that brings us to the encoder's third page, which can be accessed by pressing the encoder twice and holding before turning. We'll go into more detail on these different things in the future. The switch in the bottom right turns the CV control on or off. And that is Makutu in a nutshell. Hopefully this gives you some ideas of how you can use it in your future patches, and I appreciate you taking the time to watch this video.